Hey everybody, welcome to TCP Talks with Jonathan Baker and Justin Broadley from the Cloud Pod. In this series, we're bringing you interviews with the best and brightest leaders and heroes from the tech and cloud industry.
Jonathan, welcome to the show.
Good morning, Justin. Who are we talking to today?
Today, I have a fantastic guest for us. We're talking to Ben Kehoe, Cloud Robotics Research Scientist at iRobot and AWS Community Hero. And he is a hero for all things serverless and Lambda with Amazon.
Excellent. I love serverless.
I do too, and Ben is a fantastic guest. He's very active on Twitter. He's a very big community person in the Lambda serverless world, and a lot of the great features and functionalities. I think he probably had his influence on a little bit with his relationships he has with AWS and with the community as a whole. So, really great talking with him. Super happy to have him here on the show.
Excellent. Let's get into it.
Yeah, hi, I'm Ben Kehoe. I'm a cloud robotics research scientist at iRobot and an AWS Serverless hero.
We met about a month or two back when we got together for a couple Amazon YouTube videos that are out on the internet about serverless and serverless at my day job. But you've been pretty active in the community for a long time. You're someone I initially really followed on Twitter. When you talk about cloud Twitter, you're one of the people whose names comes up really quickly. How does it feel to be sort of known to be famous for that?
I am deeply uncomfortable with public recognition. But I am very grateful for the praise that people give me.
Well, it's definitely we have a similar feeling here at the Cloud Pod, where we started to get kind of reputation, and people kind of know who we are now, and we're starting to get recognized more. And it is a little weird sometimes that celebrity that comes with something just so meaningless as Twitter, or something like a podcast. But we think we're doing interesting work, and you're definitely doing interesting work as well.
Well, thank you.
Let's kind of jump into some conversation about this. So I know, you're known as a serverless hero. That's part of your role through Amazon. They've dictated you as a hero, which is great. But I was actually kind of wanted to take a step further back and talk about when you were first exposed to serverless. When did it go from that moment of like you were working on a POC to, wow, this is an amazing technology that I want to get passionate about and I really want to do really cool things with. When did that happen? And can you help me through that story?
Yeah, well, it really sort of, so I'm a roboticist by training, not a cloud engineer. So I was in grad school for robotics. And at the end of my PhD, I was working on a project because roboticists have lots of code that they write. And, you may have heard about sort of problems of replication in the sciences and in various academic disciplines where, this problem in robotics is people will write a paper and it's based on some code that they've written, some data that they've collected, and often none of that is public. And so it's very difficult for other researchers to then build on top of that or verify those findings or, that kind of a thing, or benchmark even. And that's not for lack of interest in this, but often it's sort of, even if you put your code up on GitHub, another developer is going to be stuck, another grad student is going to be stuck trying to get that code to build on whatever robotics platform they're running on, collecting data and, all of these things. And so I had the idea, this was 2014, of like, if it was easy to package up the code that you wrote, do some annotations on it, and have a framework that would then deploy that as a web service, that would make it very easy to provide that algorithm that you've designed as a service to other researchers. And so it started, but again, being a roboticist, I didn't really know what I was doing. I was looking at Docker as like, okay, well, this can, help them package up their environment and stuff. But when I got to what happens when the paper comes out or you go to a conference and you announce it and a bunch of people want to try it out, how does it, not choke, and B, not cost you a ton of money, because when you're an academic, money is always scarce. And so then in 2014, Lambda was announced, and it was like, oh, hey, this looks like it does a lot of the things that I think are hard problems in this thing that I'm working on that I don't know how to do. And so I got interested in Lambda right when it came out. Then I graduated without really finishing that project and went to iRobot. And I was interested in iRobot because cloud robotics is interesting when you have scale, and iRobot sells a lot of robots. And so as part of that, I was able to convince the organization to build the cloud application that we had there in a serverless manner. And so it wasn't really a case of building a POC. It was really joining an organization and convincing them to go all in on it before we really had all of the pieces proved out, because of that value proposition that serverless has, where you're not dealing with the same level of operational issues when you own all the things you own in a traditional architecture. All the ways that you don't have to learn as an organization all of the operational techniques for building and maintaining scalable cloud architectures. All of that just comes for free when you're using a managed service. So that was sort of the beginning of my journey.
Do you think Lambda or serverless in general has provided opportunities for things like deploying less smart robots and then giving them the smarts in the cloud dynamically, or do you still run all the smarts on the machines themselves?
Yeah, so cloud robotics has a number of valuable aspects to it. So one is offboarding computation. The other is offboarding storage, right? You get access to vast amounts of information that you couldn't bake into a device. You get to connect robots to each other. So, ideally, when one robot encounters something, all robots should be able to learn from it. You should be able to connect them with humans, right? When a robot encounters a problem that it can't, that it doesn't know how to solve, it should be able to ask a human for help because we're good at solving problems. So all of those are aspects of cloud robotics. Now, which of those present themselves in individual situations varies based on the context. So in industrial robotics, where you have a very controlled environment, the ability to have that compute, local to the environment, right? You can have mobile robots, and then have a big, sort of data center on site where the latency is measured in microseconds. You can do some very complicated and interesting stuff to offboard computation from the robots. For consumer robotics, it's a little bit of a different story because in general, you need a robot that's in a person's home to be fully autonomous. And consumer Wi-Fi and consumer internet is much less controlled than what you might have at an industrial location. And so you often need to have all of the brains for autonomous action inside the robot. Now you can also offboard some computation because you have access to more computation in the cloud. So you can do these techniques where basically you say, all right, on the robot, I'm going to start trying to figure out this problem, but I'm also going to send the problem to the cloud. And if the cloud comes back first, then I'll use that smarter answer. But if if I don't hear back from it for whatever reason, the cloud is down, the internet is down, the Wi-Fi is down, whatever the reason, I will always end up with an answer myself and be able to take action on that. Does that make sense?
Yeah, totally. It makes a lot of sense. I haven't really thought about using it in that way.
We're starting to see a lot more of those aspects brought into commercial products. There's a lot of home robots beyond the existing market that are being tried. This is Jibo and Anki, and they're all trying for sort of a social interaction. Well, that requires a lot more interesting cloud technologies to enable. They also haven't found the right value proposition for the amount that they cost. And so there's an interesting, sort of business and product question there, but there's also interesting cloud questions that come up when you start having those very interactive Alexa-like. And part of the problem is that they haven't figured out how to go beyond the Alexa use case, right? When it's essentially something that could be an Echo with googly eyes on it. It's not super compelling when it costs $1,000, but when the robotic action of it can start to grow beyond that, I think we'll start seeing a lot more innovation and a lot more hard cloud problems to say, how do we enable this robot to get its answer back in low latency? So this is where compute at the edge, and when you say the edge, it means lots of different things. There's various edges that people refer to, but I think for this sort of situation is, this Lambda at edge or Cloudflare workers, where the compute is happening in a POP that's local to the geographic area, closer than a cloud region, that your latency is now in the single-digit millisecond range or lower, and you can do a lot more interesting things there.
As a side note, I was interested to see or listen to the Google product announcements, and specifically that they're giving their home devices a lot more compute power than they used to have, especially with their tensor cores, so they can run voice recognition and things locally instead of having the additional latency and compute, I guess, that they have to pay for in the cloud.
Well, you could also imagine a serverless world in which, your Google Home has crunch that a smart home device could rent from, right? Mm-hmm. You can imagine that there's, I have zero idea how you would make that work, but the idea then that you would have, a POP that's even closer, be like, well, there's AWS Outposts now, right, where they give you like a shipping container, or maybe it's just a rack mount, but they give you AWS hardware to run in your data center. There are definitely compelling use cases for that. They're few and far between, but it would sort of be the same notion, but in the consumer space. How do you bring extra compute into a person's home in a way that would enable whatever companies are wanting to do inside the home?
But you mentioned Google, and you're a serverless hero on the Lambda side right now. But do you think that if edge devices become more things like HomePods and Google devices, et cetera, do you think that then that forces actually a multi-cloud problem for Lambda or serverless or fast in general? Or do you think that's kind of overblown when people are concerned about being locked into something like Lambda?
If we were talking about consumer compute, I think it would probably just go along the lines of the existing smart home ecosystem problems, right? When you buy a device and it works with Nest or it works with Alexa and only one or the other, right? Or, some of those local, is it Zigbee or is it any of the other, non-Wi-Fi networks that you would run into? Essentially, it would just get folded into that larger discussion. As for the multi-cloud piece, I don't think, again, as a business, you'd probably be faced with a similar choice of saying, which ecosystem do I want to live in, and then align your compute choices accordingly. I guess it would depend on whether there was a discount for the communication between them, right? If you were, for example, running, a function on a HomePod or whatever, and using AWS as your cloud provider, your difficulties would probably just stem from the difference in programming model. It's not like if you were using GCP as well, you'd be getting a discount on the traffic in, or maybe you would. Like, that would be, I think, where the lock-in might come in. But again, this is all supposing that people would accept having a little device that just burns up electricity.
At the pace that we're seeing Alexas get acquired and HomePods and all these things, it seems like that's something people are willing to pay for today.
Well, yes, but that's sort of the thing, right? So when you put a TPU inside there, right, and let all the smart home devices inside the house all burn compute on that, and all of a sudden you've got like a 1,000-watt device that's just continually running in your living room.
Can I ask you about kind of your more early kind of history, Ben? Like what first got you interested in robotics or computers or any of this stuff to begin with, as a teenager?
Yeah, I mean, I've always liked making things move and understanding how things work. I worked as a carpenter for theaters, so I built sets during college, and I chose not to do that as a career beyond college. But the notions of, building things, understanding how they work has always been, a thing that I've done. After college, I was trying to figure out what discipline I wanted to go to grad school for. So I went and I worked as a software engineer for a couple of years, and there figured out robots are fun. Why not do that as a career?
I totally agree. I've been playing with Technics Lego and Mindstorms since they've been around. Do you have any advice for students now, in choosing a career? Should they? Is it their growing field? Is it something they should be going into, or is it going to dead end with artificial intelligence writing software for us?
I think robotics definitely a growing field and will continue to grow. I think the important thing to keep in mind, and this is useful in any career, but especially robotics, is that the first thing is that it has to be solving a problem that users have. And if we look at these social robots that have come and gone, a lot of it is, what exactly, like, it's interesting, it's fun, it's clever, but what problem do users have that it's solving? And until we figure that out for social robots, it's not clear that they'll get any traction. And so I think that's always it's a stay customer focused, right? And it's easy with robotics because the technology is hard to get focused on the technology. And that's the same thing with serverless, right? Serverless is stay focused on the business value that you're creating, not on the technology problems that you're tackling.
So, having used Lambda for as long as you have in your role, where do you feel it's let you down and you'd like to see them potentially improve it? Or do you see that the days of being very highly focused on something like Lambda are kind of going more in the era of serverless and going with a serverless platform type offering on top of them instead? How do you see that kind of happening?
I mean, I'm always looking for ways in which I can write less code and own less of the system that I'm building, right? And so this is where, if I'm trying to orchestrate a set of services, step functions is better for that than Lambda, right? And so I think that notion goes towards there are more things that people do today in Lambda that could be moved outside of that. Something that I'm interested in is today Lambda doesn't really handle circuit breaking. So if you have a downstream system that is having an incident, right, the Lambda that's trying to contact it should ideally understand that and cease to call it as often until it figures out that it's back up, and then should start talking to it again. And if that Lambda is reading from a queue, that needs to be managed so that the queue just starts backing up, right? And you can do that today with Kinesis, because Kinesis is ordered, right? Your Lambdas, however many shards you have, is however many callers will invoke the downstream service and fail, and then that shard will just start backing up. We can't do this today with SQS, and so you can build something to do this, right? It's a stateful problem. Somewhere you need to keep the state that says this downstream thing is not working. And so you can put that somewhere. You can maybe use a CloudWatch custom metric with an alarm on it that triggers a Lambda that turns the concurrency down on that original Lambda function, and then needs to, over time, size it back up to check on it. But all of that is just undifferentiated heavy lifting. And instead, I want a system where somehow is able to, inside the Lambda function, indicate I'm erroring out, and it's because there's a downstream dependency that's down. And then Lambda keeps track of that state, of that metric, and appropriately decides, we're going to down throttle this Lambda or entirely stop it, and then 5 minutes from then we'll try again. And if it's back up, then we'll try a little more, do all the things that circuit breakers do and that container folks get out of systems like Envoy and STO and such, that we in the serverless world just don't have a standard solution for, a managed solution for.
So you think that's something that should be built into the platform itself?
Oh, absolutely.
I'd agree. I mean, I guess you could kind of solve it with step functions right now, in that you could attempt something and then exponentially back off retries until you either completely fail or are successful. But it's a little clunky.
Yeah, absolutely. You can build it, but everyone has to build the same thing. And if everyone's building the same thing, that should be a provider problem.
Yeah, it's like global optimization. Why push that concern to everyone when it can be solved at a platform level? I agree with you. I think that makes sense.
So do you have any wishes or any predictions, Ben?
I think in terms of wishes, we're starting to see people ask for things that blur the lines between what is best for containers and what's best for functions. And in a lot of those cases, I'd rather see Fargate be brought up towards Lambda than see Lambda brought, add features that go sort of downwards towards Fargate. So, I don't want to see the Lambda timeout increased, because that's just going to encourage people to do things that might be more appropriate as a container task. I'd like to see, the more stateful you need your compute process to be, to have that added on the Fargate side. So I'd love to see, the event source mappings that Lambda has, bring all those to Fargate. So it's very easy to say, here's my container, run it with the input from this Kinesis stream. And so I think that would look, some of the interesting features from Google Cloud Run, right, which says if you've got a web server, you can just drop that container into Google Cloud Run and get serverless benefits for it. And that's really cool, right? You get the service handling the request counting per container, so it knows, instead of trying to auto scale based on some proxy metric for load based on CPU usage or memory or whatever, just say, this is how many requests it can handle at a time, and scale based on that, right? That's a really cool feature. Now, what I don't want is people to get the idea that it's 6 of one, half dozen of the other between the Google Cloud Run model and the functions as a service model, right? If you have the choice, go with functions as a service, because then you own less stuff. That being said, the Google Cloud Run model is useful for people who have existing things. And so figuring out sort of the marketing angle of that as pitching it as a step up if you have something, but a stepping stone to further serverless services for compute is something that I'd like to see providers figure out.
That's great. Did you ever have any challenges from the security perspective when moving to serverless? I mean, if you're deploying an EC2 or any kind of virtualization platform, the security teams often wanting to install agents. They want control over the building of the images.
I think my experience has been that security folks like serverless because those agents tend to be required for things that don't happen in serverless, right? They're watching for OS level things. Now, at the same time, if I don't put my Lambda in a VPC, sure, there's no network traffic in. It's just not possible. But I also get zero visibility into the outbound traffic unless I'm using an agent that allows me to track that. And those agents, how can you be sure that they're actually inside the code, right? Because it's installed in the same place. Now I can put it in a VPC, but if my Lambda function is contacting AWS services and those services don't all support private link, then I need to open that VPC up to traffic to the internet, and I can't really tell anything about what's happening inside that traffic. Could be going to, some other user's EC2 instances because IP addresses aren't separated between AWS services and customer IPs. So what I'd like is the ability to have a checkbox on Lambda that says, I don't need this in a VPC, but the only thing it talks to are AWS services. So in general, then it's either going straight to CloudTrail, right? So I'll get the visibility there and don't let it talk to any other source. The other thing that I'd like is some of those, layers provide some of this, but the ability, we've got the ability for the custom runtime, which can then surround everything that's user code that goes on there. But there should also be a mechanism for, I'm not using a custom runtime. I'm just running, Python 3.7 or whatever. But I do want a layer that I can be guaranteed is running. So that I could bring some of those third-party agents into a Lambda function and have infrastructure level visibility into knowing that it's running.
Yeah, I guess layers only really provide you sort of file system layering. It doesn't let you filter the compute or filter the data in and out.
Well, you get one layer that can filter the compute if you bring a custom runtime.
We looked at solving this kind of problem with Lambda with SOX proxies, which is something else we have to deploy. But again, that can't be serverless because of the way that works. It would be nice to see sort of traffic mirroring rolled out for Lambda as well as VPCs now. That was a bit of a hole.
Yeah, well, with the VPC cold start problem solved.
Finally, thank you.
Yeah. It's not a problem that I experienced, but it's a problem that I can imagine how tedious it was. If you want to do traffic mirroring, just dropping it into a VPC is no longer a big hassle other than, IP address exhaustion, those kind of things.
Yeah, thankfully, even that's not so much of an issue anymore. So what do you think's next?
As I've written, serverless is a state of mind, and so it can be brought to sort of any situation, right? Robots are fun, and applying the serverless mindset to robots is as much about, figuring out what the business value of the robot in a particular application is, as much as it is about the cloud technology applied to robotics. Does that make sense?
Yeah, definitely. I think we're kind of heading to a place where we stop even thinking about the resources that we rent from Amazon and Google as even being infrastructure and being simply just part of the application or part of the data flow that we build.
I think there's sort of a balance there. There's, these low code and no code platforms, which I think we'll see a lot of growth in. But there's also this notion of, abstractions, people who are building cloud applications but want to build abstractions over them, or rather they're tool builders who want to create those abstractions. And the problem I see there is today, if you package up, a serverless repo app, the likelihood of you never running into a problem of something with the infrastructure inside it, whether it's, running into concurrency limits or something like that, is you're going to run into a problem with it at some point. And so you need to be able to crack it open and look inside, where a low or no code platform, like that's just the responsibility of the provider to figure that out. But when it's, sort of abstracted components in a marketplace where you still own the infrastructure that's underneath, it's just been sort of tidily packaged up for you. I think we're a long ways off from that being capable of doing that, where we don't actually need to pop the hood and get our hands dirty, which I think has consequences for how we build those abstractions, particularly just about, sort of abstracted cloud applications, where somebody figures out I can wire together some, these 3 services, these 4 or 5 services to do some subset of an application that's reusable. And so I can build an abstraction over this. And people build these abstractions in SAM, they build them in the CDK, they build them with a number of different tools. And all of them purport, the idea is we'll just use this thing and it should just work. And while that's generally true, at some point you're going to run into a situation where it doesn't. You really need to be able to, the tools that you're using and the abstractions that you're presented should help you learn how to open them up and look inside. Because until we can say you're never going to have to look inside, the moment at which it hasn't helped you to understand what's going on inside, you're just getting thrown into the deep end.
Especially when you think about things like APIs being deprecated or even services being deprecated. Or
again, it's one of those cases of, sure, you can, in theory, always just rely on it, but often the truth is more complicated. And so you need to go in with eyes open to understand what you might have to worry about.
That's really fascinating. I think we're out of time here, but thank you, Ben, for coming and joining us. And it was a great chat. And I really appreciate your insights. Where can people follow you on the internet to get these insights every day?
Yeah, well, first of all, thanks for having me. I'm on Twitter at Ben11Kehoe, like 11, the numbers. And yeah, it's probably the best place. I'm also blog on Medium.
We'll hopefully maybe have you on the show again in the future. I really appreciate you joining us.
Great. Thanks for having me.
Thanks, Ben. Visit thecloudpod.net to subscribe to the show, join our Slack channel, or sign up for our weekly newsletter. You can also find information on reaching our audience through a CloudPod sponsorship opportunity. A big thank you to today's guest, and thank you for listening.